On page 8, we're going to look at two more examples involving compound interest, and then we'll turn our attention to the future value of an annuity formula. Okay, so let's take a look at example 10. Okay, in a suburb, housing costs have been increasing at 5.2% per year, compounded annually for the past 8 years. A house worth $260,000 now would have had what value 8 years ago? All right, we first saw this problem in example 5. Okay, I think I flipped back and I saw that was example 5F. Okay, so let's go take a look at that. Okay, so here it is. Okay, if you read through it, there's the same problem. Okay, when we talked about this problem back in example 5, we said this was a compound interest problem, and specifically it's something called an inflation problem. Okay, so remember what inflation is. I think I gave you the example of a gallon of gasoline. Okay, so maybe in 1950 a gallon of gas was much cheaper than it is today. So the idea of inflation is where you have this one quantity whose value has increased over time. Okay, so gasoline was much cheaper back in the day as opposed to what it is today. Okay, so in this particular example, you have a house. I mean, this is true, all the time. If you have a house, typically you buy your house at a certain price, and you could go through a period of time where housing prices increase, and so the value of your home increases. So you have the same product, your home, and its value is increasing throughout time. So it's just different time periods. The value of the same product has increased from one time period to another. Okay, so that's what inflation is. Okay, we labeled this problem back in example 5 as a compound interest problem. So let's go back and talk about why. Okay, so remember, if you have this example, if you think about this being your house, okay, so if you read the sentence, it says the house is worth $260,000 right now, okay, and you're trying to figure out the value of this house 8 years ago. Okay, so you're going back in time by 8 years, okay, and you want to know the value of the house back then. Okay, so whatever this value of the house was, okay, that value of the house was this one lump sum that has grown to now be a value of $260,000. Okay, so since it's this whole idea of this one lump sum, okay, that makes this a compound interest problem. Okay, so inflation will always be a compound interest problem. We labeled that on the formula sheet a few videos ago. Okay, all right, so let me get our formula on here. Okay, so we're going to be using the compound interest formula. Okay, let's go ahead and figure out what we're looking for in the value of all the other variables. Okay, let's do the obvious ones first. We know our interest rate is 5.2%, so I'm going to change that over to a decimal, so it's going to be 0.052. Okay, the interest is compounded annually, so that means ILM is going to be 1. Okay, and remember, the housing market, the prices have been increasing for the past 8 years, according to this problem. Okay, so your time is going to be an 8-year period we're looking at. Okay, so now we've got to figure out our A and our P. Okay, so one of these is what we're looking for, and the other one we know. We've just got to figure out which one is which. Okay, so again, I shouldn't have erased that, but think about what I had up earlier. So right now, the house is worth $260,000. And then we're thinking back 8 years ago, okay, where the house had some value, okay? So common sense is going to tell us, okay, if housing prices have been increasing for the last 8 years, that this number we're looking for, this is going to be a smaller amount than $260,000. We expect the answer to be something smaller than $260,000 because whatever price the house was worth, okay, it needed to increase to be $260,000 right now, okay? So kind of think of this, what we're looking for is the original amount. And now this $260,000, that's what it's grown to be, okay? And it's a little confusing here because the problem uses the word now, okay, which would imply the present, okay? But it's almost this 260,000 is pretty much the future value, okay? The house was originally worth P dollars. We're trying to figure that out. And it grew in the future over this 8-year period to be a $260,000 property. Okay. So we're actually looking for the P value here, the original worth of the house. Okay. And it grew over an 8-year period to a future value of $260,000. So $260,000 is your A value. Okay, so don't let this word now confuse you. Okay, 260,000 is the A value here, not the P value. Okay, all right, so let's go ahead and plug all this in and solve. Okay, so here we go. Let's go ahead and set it up. Okay, if we plug all of this in, let's see here. I'll do it down here where I have some room. So we're gonna have $260,000 is equal to P times 1 plus 0.052 divided by 1 raised to the m times t power. So this is how you would set everything up. Okay, you're solving for the P value. Okay, again, you're expecting a number less than $260,000 or you've done something wrong. Okay, so essentially we want to solve for P. Okay, so you need to get P by itself. Okay, so let's look at what we've set up here. Okay, this P value is multiplied by this quantity in parentheses. Okay, and that quantity in parentheses is just a number. We can go into our calculator and we can figure out what 1 plus 0.052 raised to the 8th power is, okay? And that is what P is being multiplied by, okay? So I'm going to go to my calculator and figure this out. So we're going to get 260,000 is equal to P times, let's figure out what P is being multiplied by, okay? So we're going to have 1 plus 0.052 divided by 1, which you don't have to put in the calculator because you can do that in your head, okay? Same with the exponent. The exponent's going to be 8, but again, you know, you want to enter it in. Just be careful with your syntax. Okay. So here you go. This is what P is being multiplied by. Okay, and we are going to have to carry all of these digits. Okay, so that we get the correct answer. Okay, you don't want to be off by a few dollars or cents. You don't want to. Okay, so let's go ahead and write this down. So this quantity right here in parentheses with the exponent, it is 1.500119714. Okay, and then that's what P is being multiplied by. Okay, so now if you want P by itself, since P is being multiplied by that number, you need to divide this number off. Okay, so whatever you do to one side, you have to do to the other. Okay, so here we go. I'm going to go back to our calculator and enter this in. Okay, on the right, this decimal is in the top, and in the bottom, it's going to cancel. It's going to leave us with P. Okay, so let's go back to our calculator and enter this in. Okay, all right, so we're going to have 260,000 divided by, you're going to have to enter in all these digits, but remember the little shortcut. You can hit the blue, on my calculator, it's the blue button, second negative sign down here. See where my arrow's hovering? If you hit that, it will pull up the previous answer. Okay, so it will divide by that 1.500 blah, blah, blah number. Okay, and if you don't like that feature or you can't find it, you can just enter everything in. Just be careful you enter it in correctly. And then here is your answer. Okay, this is a dollars and cents amount, so we are going to have to round it to the nearest cent. Okay, so let's go and write this down. Okay, so our P value is this. All right, so let's go ahead and round it to the nearest cent because it's money. So we have 50 cents. We look after the 50, we have a 0. So that means we're going to keep it the same. So the original value of the house is $173,319, or sorry, $173,319.50. okay? And that is a sensible answer because it is a number less than $260,000, okay? This is a reasonable amount for a house, okay? And its value is increased at this 5.2% over an 8-year period to now be $260,000, okay? So that is how you do this problem, okay? So again, this was an inflation problem, okay? That goes hand in hand with compound interest, okay? Let's try the last compound interest problem, okay, which is example 11, okay? All right, so we've got a person with $14,000 who is trying to decide whether to purchase a car now or to invest the money at 6.5% compounded semi-annually and then buy a more expensive car. How much will be available for the purchase of a car at the end of 3 years? Okay, so what's going on here? And this is something you might find yourself, a situation you might find yourself in one day. Okay, you are trying to buy a new car. You have a certain amount of money at your disposal right now. This person has $14,000, and they're trying to figure out, okay, so should I go spend the money right now and get a car? Or should I wait a little bit longer and invest the money for 3 years, and then I'll have a little bit more money and I can buy a nicer car? Okay. So this question is really, all it's asking is, it's not asking the choice that should be made. It is just asking that if the person did decide to invest the money for 3 years, how much would be available to buy a car? Okay. We did first see this example back in example 5, so let's go take a look at that. Okay, so let's see, where is this problem? Maybe it's on this page, let's see. Wrong way. Okay, so there it is. Okay, so here it is. This was example 5C. Okay, we labeled this as a compound interest problem. Okay, again, it is because of this whole notion of a one lump sum. Okay, the poor person, if they're going to save up for a slightly more expensive car, they would be investing this one lump sum of $14,000 into their savings account and letting that one lump sum grow into a larger amount. Okay, so that's why we labeled this as a compound interest problem. Okay, all right, so to work this problem, we are going to use our compound interest formula. Okay, and I guess I will go up here and remind you for your notes that this was one lump sum. All right, so again, the issue here, what we're trying to figure out, we're not trying to make the decision, okay? We're just trying to, look at it from the perspective that if the person decided to save up for a more expensive car, we're trying to figure out how much that person would have to spend in 3 years, okay? All right, let's figure out what we're looking for and what we know. Okay, let's do the obvious stuff first. We know the interest rate is 0.065 because it's 6.5%. The interest is compounded semi-annually. Remember semi-annually? Go back and refer to the little box we did with the M values. If you don't remember, semi-annually means every 6 months or twice a year. So M would be 2. Okay. Time, the person's going to save the money for 3 years. So T is 3. Okay. Again, we're having to decide between A and P. Which one's the variable? Which one do we know? Okay. So again, use knowledge of money to do this stuff sometimes. Okay. It can help. Okay. The person is, P is the amount that would be invested. Okay. And then A would be the account balance or what the account has grown to be in the future. Okay. This 14,000, that is your P value. That's how much the person would put in the bank to invest. Okay, that's that one lump sum deposit. Okay, and that amount needs to grow to be a larger amount. Okay, so the person will be investing the $14,000. That's the original deposit, the P value. Okay, and it'll grow over a 3-year period to be a larger amount. So the account balance in 3 years should be over $14,000. Okay, so that's the kind of answer you should be expecting, something that's bigger than $14,000 because the money's growing. Okay, like I said, do these little checks to make sure you're doing the problem correctly. Okay, all right, let's plug everything in and then solve. Okay, so let's plug into our formula. We're looking for A. Okay, so we're gonna get 14,000 times 1 plus 0.065 divided by 2 raised to the 2 times 3. Okay, so the good news is that A is the easiest variable to solve for because you just have to plug it in exactly like you see it into your calculator. Okay, so let's go ahead and do that. Okay, again, remember you can just enter it into your calculator in one swoop. Okay, all right, so let's clear this out from the last problem. So just enter it in as you see it. So 14,000, open parentheses, 1 plus 0.065 divided by 2. Okay, close your parentheses, raise it to the power. Okay, make sure, either do the exponent in your head. 2 times 3 is going to be 6, or if you need parentheses, make sure you use them if you need them. Okay, so this is how you would enter it in. All right, so we're just going to hit enter. Okay, and there is our amount. Okay, this is going to be dollars and cents. You need to round it to the nearest cent. Okay, so let's go ahead and write this down. Okay, so we've got our A value is this. This is what came out of the calculator. All right, so let's round. Okay, so we have 66 cents. The number that comes after is a 1, so we're just going to stay the same. Okay, so that means that the person after 3 years, that account balance is going to be $16,961.66. That's how much the person will have to spend on the car if they take the $14,000 and invest it for a 3-year period. Okay. All right. So now we're going to turn our attention to practicing with the future value of an annuity formula.